This is section 2.4, exercise 27. And so here we're told y is equal to x over the square root of x squared plus 1. So now in this case, I think I would just go ahead and use the quotient rule, but we're going to end up with a chain rule from this bottom part, the denominator. So I'm going to go ahead and use the quotient rule to start with. So y prime, derivative of the top, so dx with respect to x, times the square root of x squared plus 1, minus x times the derivative of the square root of x squared plus 1 with respect to x, all divided by the square root of x squared plus 1 squared. Okay, so this first part, no big deal. Derivative of x with respect to x is 1. But here, as I do that derivative, again, what I have to notice is I have these two composed functions. I have the x to the 1/2 or something to the 1/2 function, and I also have the x squared plus 1 function. Derivative here, 1/2 to the negative 1/2 because I subtract 1. And then here I get a 2x plus 0. So this one, I just get 2x. Okay, so that's my derivative that I deal with here. And so this is equal to 1 times the square root of x squared plus 1 minus x. Now, here is that whole derivative I need to do. And so there's 1/2 to the negative 1/2. Now be careful here. Remember that square root was the 1/2, so this is just x squared plus 1 and then times our 2x that we had over here. And then all divided by, well, a square root squared, we just get rid of the square root, and so I get x squared plus 1. Okay, so this is equal to the square root of x squared plus 1 minus, now let's look here, whoops, careful there, that 1/2 was from this stuff over here. I only have so much room here, so hopefully I don't screw up by accidentally pulling something in I shouldn't. So I have my x squared plus 1 under the square root minus, now you see I have an x here and an x there, so there's my x squared. I have a 2 here and a 1/2 there. They cancel to make 1. And so I have x squared times x squared plus 1 to the negative 1/2, and then all divided by x squared plus 1. Now, at this point, various things I could do. For one, I've got the square root symbol here, but the negative 1/2 symbol there. Maybe I should clean that up a little bit, and I can make this minus and then x squared over the square root of x squared plus 1. And then all divided by x squared plus 1. And this is fine. Now I could go with a common denominator up here and get the x squared plus 1. So this is a bunch of algebra. Doesn't have to be done, but just in case you're interested, right, get a common denominator here. So I will get x squared plus 1 minus x squared, and then all over the square root of x squared plus 1. And then that is all divided by x squared plus 1. And so here, notice I've got the x squared minus the x squared. So this is 1 over, now these are both in the denominator because I invert and multiply. And so I have x squared plus 1 times x squared plus 1 to the 1/2. Oh, I could write that as x squared plus 1 to the 3/2. And so what's nice here is, why the simplification? Well, if I have to take a second derivative, I would much rather take the second derivative of that than that. They're equivalent, should give me the same answer, but I would much rather take the second derivative of this thing down here. So that's what simplification does for us. Not sure what happened here as to why, let's see, x squared plus 1. Okay, but anyway, so there is our answer to, what the heck number was that again? Number 27. So there we go. There's number 27.